Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS. In the previous lecture, we were doing numerical analysis of statistics paper 1, in which we did forward and backward formulas. And in today's lecture, we'll do some of the questions based on forward and backward formulas so that you can understand what type of questions come in the examination and how do we solve them. So let us take first example in which we have been provided with a second degree polynomial. The question is a second degree polynomial passes from points. We have been given some points which are 0, 1, 1, 3, 0, 1, 1, 3, 2, 7, 3, 13. 2, 7, 3, 13. These are the 4 points that the second degree polynomial passes. Find the polynomial. We have to find the polynomial. Now in this we'll be using forward interpolation formula, in which we'll first we have the function. Let us suppose we have the function as a x square, because it is a second degree polynomial, plus bx plus c, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. For if we have to find out this, we have to make a table like this. Let us make a table. Since it is a second degree polynomial, so we'll make the table up till second degree only, which is for in first function we'll take x, in second function we'll take fx, and in third function we'll take delta fx, and in fourth function delta square fx. There wouldn't be anything more than the delta raised to the power 2, because we only have a degree polynomial of degree 2. X, fx, then delta fx, and then delta square fx. Now we have been given a point, these 4 points. These 4 points. So the points are 0, 1, 2, 3 for x, and 1, 3, 7, 13 for fx. So it will be 0, 1, 2, 3 for x, and 1, 3, 7, 13 for fx. Now we have to find delta fx. Delta fx will be written in between these 2 points, because we are differencing these 2 points. So delta fx would be written here for all of them. So 3 delta fx is nothing but fx plus 1 minus fx. So for first value it will be 3 minus 1, which will be equal to 2. I am writing it 3 minus 1 equal to 2. This will be 7 minus 3. We will write them in the center, which will be equal to 4. And this will be 13 minus 7, which will be equal to 6. Now we have to differentiate them for the square value. So 4 minus 2, in between both of them, it will be 4 minus 2, which is nothing but 2. 6 minus 4, in between them, which will be 2. Now as you can see that these differences here are coming constants, 2, 2, and if it would have been followed like that, then also the next difference of the power 2 will be 2, because this is a polynomial of degree or of the power 2 only. Okay, so now since we have taken our this fx as a x square plus bx plus c, if we take it as delta fx, then it will be a into delta of x square will be x plus 1 whole square minus x square. Delta of bx will be b into delta of x will be x plus 1 minus x, and delta of c. I have told you in the forward lecture video in its formulas that delta of any constant will be equal to 0. So delta of c will be here equal to 0. That should be kept in mind. On solving it, we will be getting it as a into 2x plus 1 plus b, because plus x and minus x will get cancelled and we'll be getting only 1. So this is our formula. Now delta of fx. Delta of fx, what have we, if we put, this is the formula for delta of fx. If we put delta of x equals to 0 here, so delta of f0 should be equal to a into 2 into 0 plus 1 will be 1 plus b. Delta of f0 means delta value, first delta value will be equal to 2. So it will be equal to 2 is equals to a plus b. This is our equation number 1. Now if we put our x equals to 1, then f1, delta of f1 will be equal to a into 2 into 1 plus 1 plus b. Delta of f1, that is second value, which is 4. 4 equals to 2 into 1 plus 1, 3a plus b. This is our equation number 2. And on solving equation 1 and 2, we get the values of a and b. A will be equal to, b will be equal to 1 and 1. Okay. Now, since the polynomial was fx was a x square plus bx plus c. Now fx, let x equals to 0. So f0 will be equal to a into 0 will be 0 plus b into 0 will be 0 plus c. f0 has the value at 0, at x equals to 0, the value of fx is 1. So here we can write it as 1 equals to c. We have got the third constant, which is c. Now we have got all constants a, b and c. A and b and c all are by chance coming as 1. So our second degree polynomial is what is our second degree polynomial? Our second degree polynomial is fx equals to ax square, a is 1, so x square, plus bx, b is 1, plus x, plus c, which is also 1. This is our final answer. This is how we calculated in the exam. This has been a bigger concept because we are doing it for the first time and I have told you every detail about it. If you'll practice these kind of questions again and again, then you'll be thorough with the concept and then you can solve it in just seconds or a minute. That's the most time that you will require for solving these kind of questions. Now the question says that example 2, find the function whose first difference is there are two parts in here, e raised to the power x, and the second part says whose first difference is e raised to the power a plus bx. Okay, so this is the question. We have to find the function. We have been given the first difference and we have to find the function. Now, if we find the first difference of this, let us say that fx is nothing but, let us say that this we have been given ex. So solving first part first, we will find first difference of e raised to the power x. Now first difference of e raised to the power x will be e raised to the power x plus h minus e raised to the power x. If I can write by the exponential theorems, I can write this as like this, and this can be written as, if we take e raised to the power x common, e raised to the power h minus 1. Now e raised to the power h, if we take it on the left hand side we have been given as delta of e raised to the power x divided by 1 upon e raised to the power h minus 1 should be equal to e raised to the power x, right? Now this, because it is independent, this term is independent of x, then it can be taken inside delta function. So we can write it as delta of e raised to the power x upon e raised to the power h minus 1 equals to ex. We have been given in the question that the first difference is e raised to the power x. Now if we see here clearly, then the first difference of this function is also e raised to the power x, then our function would be fx equals to e raised to the power x upon e raised to the power h minus 1. This is our function. I hope that it's clear. Now moving on to the second part of this question, in which the first difference has been given as e raised to the power a plus bx. Let us take delta of this only. If we take delta of this, then e raised to the power a plus b x plus h minus e raised to the power a plus bx. This can be written as e raised to the power a plus bx into e raised to the power bh. I can write it like that because it would be e raised to the power a plus bh plus bx. Instead of bh in writing it in with plus sign, I am writing separately with the multiplication sign, and minus e raised to the power a plus bx. Just to take common, that's it. So we can take e raised to the power a plus bx as common, and we will be left with e raised to the power bh minus 1. Right? Now again we'll take this on the left hand side. So it will be delta e raised to the power a plus bx upon 1 upon e raised to the power bh minus 1. Okay, it will be equal to e raised to the power a plus bx. Now since it is independent, this term is independent of our term of x, then we can take it inside delta. So we can write it as delta of e raised to the power a plus bx upon e raised to the power ah minus 1, sorry, bh minus 1 should be equal to e raised to the power a plus bx. Now in the question we have been given that the first difference of a function is this, e raised to the power a plus bx. Now if we see very if we see clearly here, then we can see that this function, then first difference of this function, first difference means delta to the power 1. First difference of this function is coming out to be e raised to the power a plus bx. Then hence we can say that our function is e raised to the power a plus bx upon e raised to the power bh minus 1. This is the concept that we have to do, and this is how we find a function from the difference and a difference from the function as well. I have told you both kinds of questions that has been asked in the recent times. Many times have been asked in the examinations. These are the kinds of questions. And I hope that the concept is clear. Now you can pick any book and you can do questions on these, and as the more you practice, the more you will be clear with the thorough with the concept of these questions, and the more quick you can solve it in examination. These are easier ones. Okay, if you will be solving it in the examination, then you just have to solve till here, and you will be knowing that if I divided this by this function, then it directly I will be getting e raised to the power function as e raised to the power a plus bx upon e raised to the power bh minus 1. All of this is just for understanding the concept for the very first time. After that, you will be so quick in solving these that you won't be coming to these steps. You will be so quick. So I hope that whatever we have done today in class are thorough with all of you. And if not, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. And we have recently launched our Lakshya 2027 batch, in which many of the people are enrolling. And if you are interested and serious about ISS preparation for 2027, then you can enroll in our batch, which will begin in July 15th, 2026. As and when you want to contact us, you can contact us with the WhatsApp number given in the description. We'll reach you out about the program. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.